So moving on to the schedule, this is what we're going to be doing today. We'll be starting with what are fidgets. So what actually, what are these things, who uses them, and what can they do? After that, we'll be taking a look at the getting started kit. So again, everyone should have this, and we'll just show you how to use this and what resources are available for it. After that, we'll be doing a code review. So we'll be, again, looking at this sensor actually. So this is a distance sensor that measures, you can measure distance with. So we'll just be doing a short code review. We won't get really technical, but we will be kind of just showing off the code and just getting a feel for it so that you're used to it. So the first thing that we're going to talk about is what are fidgets. So as we see on the slide there, they're programmable USB sensors. So every fidget looks something like this. So they have this black enclosure. They kind of fit in the palm of your hand like this, and they generally do one specific task. So, this one is a distance sensor. So it measures the distance to my hand. So this can measure from, less than an inch to about 30 feet. That's one example of a fidget. Another fidget I have here is a thumbstick fidget. So this would be used for user input in a, game. Another example here is a spatial fidget. So this has an accelerometer, a gyroscope, and a magnetometer. So lots of fidgets. There's hundreds of these things available. And if you're following along here, you can see the sensor list here, just to give you an idea of how many sensors are available. So 161 sensors. So if you scroll down, you can probably find a sensor that would work for you in your project. We also have controllers. So controllers are just things that you're not sensing, you're controlling. So motor controllers, DC motor controllers, servo controllers, things like that. So we have a bunch of these as well. And feel free to browse this as we're talking. And we'll also talk about later about pricing and how that website that you're seeing there is our kind of consumer facing website. We also have an education website. So we'll talk about the differences there. We also have other hardware. So if you are a classroom that is looking at servo motors and hardware and all this stuff that is available, and there's also discounts available for educators. You get basically the discount is 40% off anything you see on this site. So it's a pretty nice discount. So how you actually use fidgets is you would take your sensor. So today I'm going to be using the Sonar Fidget. Then you take your fidget cable. So a cable looks something like this. I'm not sure how well you'll be able to see this, but it's just a 3-wire cable. 3-wire cable there. And what you do is you take your fidget cable and you plug it into your sensor. So just like that, just clips in, plug and play like that. And then what you do from there is you take your VIN hub. So we have this device here, which is our hub, and that connects all your sensors together and connects it to your computer. So I take any port on the hub. So I'm just going to pick this one here. Again, I plug it in like that. And now I have a sonar sensor and I have a hub. So from there, what I do is I take the USB cable. So this is just a standard USB cable. I have a mini on one side and I have type A on the other side. And I'm just plugging into my VIN hub like this. So now I have sonar sensor, hub, and then I have my cable. So from there, I plug my cable into my computer, which I'll do right now. And then I'll try to put this in view. So now I have my sonar system set up. So basically, depending on what sensor you're using, if you're using the sonar and you also want to use, a thumbstick, for example, then you would just plug in the thumbstick. If you're using the sonar and LEDs, you just plug in LEDs. So very simple to get going with. From there, what you do is you write code. So we have a lot of programming languages available. For education, we have these 4 here. And I'll just show you an example of Python for a second. So this is Thonny. I'm not sure if anyone here is familiar with Thonny, but it's a nice little programming environment for Python. And this is a basic Python program. So we'll go over this in more depth later. But basically, I have 1, 2, 3 lines of code specific to fidgets. And if I press run, I'm now getting my distance values into my Python program. So pretty nice. Takes a few minutes to, or not even a few seconds, basically, to plug everything in. And then after that, you have this physical data available to you. So, if I put my hand in front of this, we can see those values change. The default it's reading is about 2 meters, which is the distance to the ceiling right now. So that's what a basic Fidgets program looks like. And again, we're going to be talking a little bit more about how the program works in a little bit. And the other thing that's pretty interesting about them is that they've been around so the company's been around for about 20 years. And in that time, we've been selling these primarily to professionals. So professional engineers, computer scientists, researchers. And we do have a link here if you're following along where you can see some examples of those. So we try to get an interview with a company once a month with our newsletter. So you can kind of browse these when you have the time. So there's some pretty cool examples here. So there's a little, I'll just play one. I'll play one for a second. This is a little part where he talks about
mostly in
fidgets.
Malaysia.
Hopefully you guys can hear this.
So the main fidgets I use are the load cells, which I basically stick on the side of the trees, which measures the bending strain. And then I use the accelerometer, the kind of motion fidgets, which we can stick up near the tops of the trees. And so this measures the swaying back and forth. And from that, we can get the fundamental frequency. And then I'm also using the versatile input fidget to measure as a interface between my anemometers, so I can measure wind speed to the same data logger.
So that's just an example of one of these things. So we talk about what they're doing in their research. Like we also talk about coding a little bit. So we've noticed that a lot of students don't necessarily understand how the skills are applicable outside of computer science class. So it's a nice way to just get that information to students and say, hey, there's so many jobs and so many different avenues available for these skills. So pretty cool if you can give that a look. So that's a kind of overview of fidgets. So again, USB sensors, plug them in, code against them, and they're professional tools. So they're it's nice because they're professional tools. You're giving your students something that's used in the real world, but at the same time, it's still kind of easy enough to use in the classroom. Alrighty, so everyone here should have their kit and their humidity sensor. So again, if you do not have it, it looks like this. It's the Getting Started kit. If you do not have it, the link is fidgets.com/education/free. So once you actually receive the kit and you have it, there is a full online tutorial for this. So if you look at your kit, if you look at the side of it, you'll see, you probably can't see it in my camera, but there's a URL that says fidgets.com/start. So if I go to it, you can see it right here. If I click on that, that will bring us to the Getting Started Kit tutorial page. So this is the tutorial page. If you want to pull that up on your computer, feel free. If not, we can just follow along on my screen here. So the first thing that you would do when you get this, get your students to this page, I would definitely recommend watching this video here. So after they watch the video, the first thing to do is to click this button here. So there's this Set My Language and Environment button that you'll see. So if I click on this, you'll see this page. So this is where you kind of configure the website for what you are using. So today I'm using Windows, Python, Thonny, but if you're using a Mac or a Raspberry Pi, that is something that you would obviously click on and make sure that it's set up for you. If you don't see your environment down here, usually it's pretty easy to kind of tell from the instructions that we have how to get started in your environment, but you can also, you can always email education. So I'll just put the link here. So that's the kind of general education email. So you can always email those, email us and we'll give you specific instructions for your environment. So the first thing that you would do after you set your language environment. So today I'm using Windows, Python, and Thonny. So I set that. I can always modify it from up here if I want to. So I click on this and it will bring down this menu again. But the first thing that you'll do is you'll start at setup and building your kit. So, this kit comes with all of the LEDs and the buttons in the box. So this will show you how to basically get everything going. So nothing too crazy here. The only thing to note is you can click on these buttons, or sorry, click on the images and it will bring up the, it'll make it slightly larger. So, the first step, you're assembling the buttons. The second step, you're assembling the LEDs. So the LEDs come pre-assembled, and basically what you're doing is you're just putting them in the correct slot. After that, they connect their hub. So this is the device that we saw earlier, the hub that we connected the sonar to. So basically, they're just connecting their buttons to the hub ports. And then the last thing that they do is they add their humidity sensor. So there is a humidity sensor included in the kit, which measures both humidity and temperature. And then the last step there is that they're just kind of putting that on their kit there and securing it on the back. So after they have built their kit, it should take 15, maybe 20 minutes. And then I guess one thing to note too is once you have it built, you can kind of give this to any student. So if you have a set of students in the morning and in the afternoon, there's no code that actually lives on the kit itself. So you can easily give this to another student and it's not going to affect them if another student previously used it. So the next step is configuring. So this is where the environment selection that you made actually comes into play. So what I selected, if we remember from here, I selected Windows, Python, Thonny. So now I'm getting Thonny instructions for Windows. So it's just step-by-step instructions on how to actually get your environment set up. So if you're familiar with Python, you may be familiar with pip, the package manager. So all I'm basically doing to get my machine set up is I'm just searching for Fidget 22 native like this, and then I'm installing this library here, and then that gets my computer set up. So it's pretty simple. And again, all the instructions are listed here, so you don't have to worry about writing anything down. And there's also video instructions. So if you click video instructions, you can see
Open Thonny.
Like stuff like this. So if you have a student
Select
who prefers
tools,
videos, they can
then manage packages.
That.
Search for Fidget 22 native.
So that would be how you would configure your environment. And then when you're done that, you will be brought back to the getting started page because you're now kind of configured and you're ready to start coding. So we have all of these modules here for coding. I'm not going to go through every single one of them today, but basically they start with blinking the LED. So they kind of start basic. They start with their simple fidgets. So we call them simple fidgets. We basically call smart fidgets anything that looks like this. So anything that has a black enclosure is a smart fidget. And then anything like, buttons, LEDs, any analog devices, those are simple fidgets. So if we click through to lesson 1, just to give an example, this is what the lessons all look like. So basically they have the navigation on the left-hand side. They have, your description, and they have a GIF showing, what you can actually expect from this step. So in this step, they're simply, writing toggling the LED. Again, because I selected Python, I'm getting Python code here. If I switch this to Java, for example, I will now get my Java code here. So pretty simple. And then what you do, I'm just going to go back, is you would copy this code. You would pull up your editor. So in the last step, they created a project. So then all you would do is you would just kind of paste your code in, press run, and then you would head back to the lesson. Oops. You would head back to the lesson here, and then you would take a look at these practice problems. So this is a way for them to kind of jump back into their code, and also a way for you guys to assess them. So we have sample rubrics that we can send out if you're interested. But basically most teachers will say, these get more difficult as you go on. So they'll do the rubrics based on that. And we also do have solutions available. So that is the blink LED step. And then they would just continue on to all the steps here. But I'm just going to go back to the getting started kit tutorial. So basically they would, jump from blinking the LED to using the buttons to kind of using both. And then the last thing they would do is they have a project here, which is a Tug of War project. So we always try to incorporate these mini projects throughout the course for assessment and also for them to kind of jump back. So basically this one is a Tug of War game. So they're using the buttons, they're counting the number of button presses, and then whoever gets to 10 button presses first kind of wins. And again, that's using your kind of conditional logic, you're using variables, you're incrementing variables, all that stuff. So just jumping back again, that's the simple fidget section. After that, they would jump into the smart fidget section. So this is where they actually learn how to use their humidity fidget to monitor or to measure temperature and then humidity. And they also have a mini project here called hot or cold. And then finally, after they do all of that, they have a final project where they kind of put everything together. So you put your buttons, your LEDs, and your sensor together, and you create like a smart thermostat. So that's the basic getting started kit. So depending on the student and the age level, that will take a varying amount of time. So I can't give you an exact amount of time. But if you do have a student who kind of goes through it faster, I would definitely recommend the advanced lessons here. So this is, again, because it's a professional tool, there's a lot of layers to kind of peel back. So we kind of dive into different things like events, Addressing is something that if you had multiple Vint hubs, so I could have, in my example, I had one Vint hub connected. I could have hundreds of these hubs connected to my computer with hundreds of sensors. And we talk about things like that. So, and we try to include pictures where we can of practical applications or real applications. So this is an example of a company that uses Phidgets, and they have, dozens of sensors. So they have one hub here, 2, 3, 4 hubs in their one system. So we try to give the practical examples when we can, but definitely check out the advanced lessons if your student is capable of that. We also have things if you're teaching, depending on the age level you're teaching, we have error handling and we have APIs. So, if we click into this sensor API, we can see for the humidity fidget, this is the API, and they can look at all the functions that are available, and it just teaches them how to use the API. It's professional API, so if they're in grade 11 or 12, this is something that they're going to be facing in university and in their internships and careers. So it's nice to get them started on that. And we have some videos here explaining it as well. So that is the Getting Started Kit tutorial. So again, if you do have this, all of that is available to you for free. And if you do want to there's this news tab up here. So if I click on this, just to show you quickly, if you do want to dive deeper into a specific language, we have all of our pre-recorded webinars here, and this is where this webinar will also live. So you can always find, so say you're using Java, you can always find a video for your specific language, and it's a longer video. So this one, for example, is a 40-minute video or 50-minute video specifically on the Getting Started Kit with Java. So if you want a more in-depth look into the Getting Started Kit, that's my kind of recommended path there. So I'm going to quickly head back here. So I'm going to move on to this next step, but I'm just going to check the comments first just to see if there's anything. I'm going to jump into using a sensor. So basically the idea here is that after your student has completed the Getting Started Kit, if I click on this Learn tab up here, you'll see the Getting Started Kit as level 1, right? So this is the on-ramp for a student to learn this professional tool. This is the kind of best way to introduce them. So after they learn the Getting Started Kit, they'll actually have the skills and the capabilities to basically use any sensor that we have or any sensor that is compatible with Phidgets. So if they want to use, if they want to use the thumbstick that we saw earlier, they have the ability to do that now because the code is not very different. It's very similar for each sensor. If they want to use something like this dial fidget, they can use that. So the idea is that after they complete level 1, they can then move on to level 2. So I'm going to click on to level 2, and I'm going to take a look again at this sonar. So that's what I'm looking for here. So basically what we have here is we have a short list of sensors that we think work really well with education. And these are also sensors that are included in our education bundles. So we'll talk about the bundles later, but we have bundles that bundle the Getting Started Kit with a bunch of different sensors. So these are a short list of those sensors. And basically, if I click on a sensor, so if I click on the sonar, it will bring me to a page that has content. So basically, describes the sensor. So this, the Sonar Sensor is an ultrasonic sensor. It gives them some information about that. If we scroll down, they have their setup here. So, this one's quite simple. It's just what I have on my desk here. And then we also have the code. So they always have base code to work from. So basically what they would do is they would copy this code. They would, again, open up their environment. So I have Thorny, and they would paste it in and they would press run. So this is what we saw earlier where I ran this code and we see the output from the sensor. So what I'm going to do now is just quickly go through the code and just give everyone an idea of what it actually looks like. So I'll do Java and Python just because it seems like that. I think there was a few Java people in here. But basically what you have is you always have these imports here. So no matter what you do, you'll always have the fidget imports. And then depending on the sensor, you will have an import here. So this is a distance sensor. So I have the distance import. If you have the humidity fidget with you, if you take a look at it in the top right corner, you'll see a label that says objects. So you can always see the object it is from there. So for example, my Sonar Fidget says that it's a distance sensor. So that's kind of like a quick way that you can see what object it is. And again, it's always on the website as well. So you'll always have your import statements. We use time here, so not just down here for sleep. So I'll talk about that later, but not super important. The first real step of Phidgets code is right here. So this is just creating our object, instantiating our object. Again, this is a distance sensor from our Phidgets library. So you're just creating your object. You can call this, height. You can call it radar, whatever you want to call it, right? So we just have it called distance sensor. The next step after you create your object is to open it. So again, this is something you'll do with every Phidgets project. And basically, this is just saying, okay, I have a software object, I have a physical device, and now I want to kind of bridge them. So regardless of what sensor you're using, this will always be the same. You'll just have a different class. The last step here is actually using your Phidget. So what we have is we just have a while loop that's kind of spinning, and it's just reading the most recent value from the sensor. So if I, again, if I press play, we'll see that update here. And now it's basically 4 times a second, it's outputting the data. So the reason we have the sleep is because the sensor has a default interval. So basically it is getting data at this rate of 250 milliseconds. There is an advanced lesson on how you can change that to make it faster. But again, that's an advanced lesson, so you don't really need to know that. And there's also advanced lessons on using events. So if you don't want to poll the device, there are events that you can use, but we basically just show them the most basic use case. And then basically what happens is it's really easy to create more sophisticated projects. So, this took me 2 minutes, not even, it took me 20 seconds to plug everything in. And then what you can do is like we had a project for Halloween where we said, hey, if distance sensor dot get distance, is less than 500 or something, we're using it as an object detector. Then we turned on the eyes of an LED of a pumpkin with like LED eyes. So you can kind of do a bunch of, there's a bunch of stuff you can do quite easily because you're not spending your whole class actually building the circuit. You're not focusing on resistors, on capacitors, on like all the electronics. You're spending your time in software. So it's really, really nice for computer science. So that is the basic kind of project for Python. And again, like if I added a light sensor to this, I could add a light sensor right here. And all I would be doing is I would just be adding like this. I would be importing the light sensor object. I would be creating a light sensor. I could just call it light sensor. And then I could do this. I could open it. And this just kind of shows you how it's really easy to start making some more sophisticated code. And then I could print the data. So basically I would say this is light. And the call for this is light sensor get illuminance. The value is lux. So I could do something like that. I can plug this in just to show everybody. So then if I'm running this code, now I'll get distant. Oops, let's see. I have a typo here. Light sensor. It's never a good idea to do live coding. Light sensor. Does anyone see my error? Oh, I see. I just haven't capitalized that. So if I run this now, we can see now we have both distance and illuminance. So if I cover the light sensor with my hand, we'll see that light value go down to 0. So again, it's really nice because you can start adding complexity. You can add motor controllers. You can add really anything you want, and you can get some really nice projects going without having to spend a ton of time on the hardware. And also, if you are doing the installation, I mentioned that we have classes that are doing like greenhouse projects and things like that. It's nice because you don't have to worry about the project falling apart. You don't have wires hanging out, and if someone bumps it, it's not going to stop working. So that's the nice thing about it too, if you want to do some data collection. So taking a look at Python or Java quickly, you can see a very similar setup here. I'm in NetBeans here, so I have this package that NetBeans requires that. But basically, I have the import here. So for Java, you have a jar file, which you can see here. So this is something that you're dragging into your project. It has the libraries. And then basically, we have the same look. We have the distance sensor. We have the open call. And then we have the get distance. So if we run this, we can see the same output here of the distance sensor. So quite nice if you're in Java. It's a nice way to add that physical component to it. So that is all we have for today. This is our contact information. So if you do have any questions, feel free to send it to education.